Okay guys, let's do a super quick video on practice with domain and range. So if we take a look at this first one right here, this is already graphed for us. It's a logarithmic function, f of x log base 3. We already know that if we were to graph it, we'd first identify h and k, think opposite on h. The k value, take it for what it is. If you wanted to actually come up with coordinates for the log base 3 of x, what you would actually do is ignore h and k. You would find the coordinates of y equals 3 to the power of x, which is really the inverse of log base 3 of x, and then switch the x and y values. But if you did all that correctly, you'd end up with this graph right here. So there's going to be a section on tomorrow's quiz where I just ask you to state the domain and range of each, right? And it'll already be graphed for you. So, what is the domain? And you could even just look at it visually and find out what the domain and range is. What would you guys say the domain is right here? X is all real numbers? X is greater than -1. That's absolutely right. Now, when we're talking about the range are your y values, which is up and down. So does this graph go down forever? Absolutely. Does it go up forever? Yes, it does. So what do we say about the range? Y equals, and you have to put y equals all real numbers. You could put the all real number symbol. Okay? So this was a logarithmic function. We stated the domain and range. It's pretty easy to see that your x values, it's at -1, and it's all to the right of -1. It's none of that goes to the left of -1. Okay, so there's going to be 3 of these right here. We're practicing 6, but there's going to be 3 of these that are on the quiz tomorrow. So is this a logarithmic function? No. What kind of function is this? What do we call this? It's called an exponential growth function. Why is it a growth function? Nobody remembers. Because the base is greater than 1. Base is greater than 1, so it's a growth function. Now normally we see growth functions like this. Check out this red dot. We see growth functions growing, right? But because the a value is negative, what happens? Instead of growing up, it's growing down. Does that make sense? Okay, so if you understand the function, which is an exponential growth function, but in a negative direction, we should understand how it behaves as it goes to the left and how it behaves as it goes to the right. So we should be able to conclude what the domain is. What's the domain? I shouldn't have put equals. That kind of gives it away. All real numbers. Why? Because this graph really does go to the left forever. And this graph also goes to the right forever. Even though it's going down, it continues to go to the right forever. The asymptote, what it infinitely approaches, is the y value of 0 or the x-axis itself, whatever you want to call it. It infinitely gets closer but never actually touches. So how about the range values? What are the range values? Y is what? Less than 0. That's right. Perfect. I hope you guys are understanding this. Looking at this next one, we have log base 2. It's already graphed for us. Now, you should remember that parent graphs of logarithms, like if you were to just look at this part right here, ignoring the h shift, you should know that it looks like this. Infinitely approaching, so it kind of looks like it's touching, and then all of a sudden it goes that way, right? Now, this graph itself got shifted h units to the right. So where the asymptote was here, now it's over here. So what's the domain and range of this guy? What's the domain? Now, what is greater than 2? X is greater than 2. How about the range? Y equals all real numbers. Anybody else understanding this? Yeah? Okay, let's check out another one. Right here we have another logarithmic function, but it got reflected over the x-axis because the a value is -1. You don't even need to really understand the the function, you could just look at it and see that it infinitely approaches the y-axis, which is the x equals 0 line. And we can see that it clearly goes up forever and it clearly goes down forever. So you should be able to conclude what the domain and range is just based off of that. So what's your domain? X is what? Just by looking at the graph, we don't even have to do any math. Greater than 0. The range is what? Y equals all real numbers. Okay, how about this guy? This is what kind of function is this one? Growth, decay, logarithmic, what do you say? It's a growth function because the base is greater than 1. We know that all growth functions start at 0 and then grow crazy, right? Now, of course, this one has an h shift of 4 to the left and 5 down. So now we have the growth function down here. Totally understandable if you understand h and k and understand that it's a growth function. So we should be able to state the domain and range. Whoa, the domain and range. So what's a domain? X is what? All real numbers. Does this line go to the left forever? Yes. Does it go to the right forever? Yes. Even though it goes up, it continues to go to the right. So x equals all real numbers. And how about the range? Y is greater than negative 5. Correct. You're at negative 5 right here. This whole graph is always above negative 5. Yes, it infinitely approaches the y value of negative 5, but it never actually touches the y value of negative 5. Now this one's a little more interesting. Why? Because if you just look at the graph, it looks like just like a slightly bent line. You can't really see what it's infinitely approaching. You can't really, I mean, you have to actually look at the equation this time and understand what kind of equation it is and what kind of shift it has. So ladies and gentlemen, what kind of equation is this? This is a decay function because the base is less than 1. So we know that decay functions, the parent graph of decay functions, start off at a high value and then decay, 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 decay until they infinitely approach 0, correct? Yes? Now, what about this decay function? What happens? What kind of shift does it have? What kind of shifts does it have? Yeah, but does it shift left, right, up, or down? It goes down. How many units? 8. So where I used to have my asymptote at 0, where it was approaching 0, infinitely approaching 0, it's no longer infinitely approaching 0. If you move it 8 down, it's going to infinitely approach what? 8, way down there. Does that make sense? You can't see it on the graph that they show you, but if it was up here, like this, well, and you shift this graph, the parent graph, you shift it 8 units down, it's going to end up being like this, way down here at 8. So if you were to extend this guy, it would go like that. And down here, this would be the negative 8. Does that make sense? Yes or no? So this graph, what's the domain and range of this graph? X equals all real numbers. Range? Greater than negative 8. Boom. I think we got it. There's only 3 questions like this on the quiz tomorrow. It's not that much, but it probably will be like 10% of your overall grade. So don't blow it off.